there, and welcome to the course Develop Generative AI Solutions with the Azure OpenAI Service, where you will learn how to use OpenAI's powerful large language models to build natural language processing solutions in Azure. My name is Georgia Kaliva, and I'm a Microsoft Technical Trainer. My areas of expertise include software development, architecting cloud solutions, AI, and machine learning. I am very passionate about two things: teaching and collecting tech stickers. Now, this course is designed to help you learn how to use the Azure OpenAI service to build powerful generative AI solutions for your business needs. And I'm here to guide you in this adventure. Here are the topics we will cover in this course. We will learn the basics of Azure OpenAI service and how to access it through REST APIs, SDKs, and the Azure OpenAI Studio. Then, we will explore the different types of models available, such as GPT, codecs, and embeddings, and how they can help you understand, converse, and generate content. We will practice prompt engineering, a technique to design prompts for natural language processing models that improves accuracy and relevancy in the responses. We will also see how to use the Azure OpenAI service to generate and improve code using the codecs models. We will explore our creativity and use the Azure OpenAI service to generate original images using my personal favorite, the DALL-E model. And finally, we will see how to reference specific sources of data using the Azure OpenAI on your data feature. Now, to get the most out of this course, you need to be familiar with Azure and the Azure portal. Some of the concepts we will talk about also require some programming experience with C# or Python. If you want to follow along with the demos, you will need an active Azure subscription and be approved on that subscription to use the Azure OpenAI service. By the end of this course, you'll be able to build apps that integrate with the Azure OpenAI service and leverage the capabilities for various natural language processing solutions by using those powerful large language models. Now, if you're ready to dive into the world of generative AI with the Azure OpenAI service, let's get started. Hi there, and welcome. In this video, we will introduce generative AI and how it relates to AI and machine learning. To keep up with the topics in this video, you need to be familiar with Azure and the Azure portal. We will have a brief overview of AI with a focus on generative AI and see how to deploy the service and use the Azure OpenAI Studio. By the end of this video, you'll know the basics of Azure OpenAI so that you can create intelligent and personalized chat experiences for your users. Let's get started. Artificial intelligence has a long and storied history that spans many decades. Some of the earliest work in AI was done in the 50s and 60s, when researchers first began to explore the possibility of creating machines that could think like humans. During the 50s and 60s, AI research focused primarily on what we called symbolic AI, which involved creating symbolic representations of knowledge to solve problems. And then they developed computer programs that mimic the decision-making abilities of human experts in a very specific domain. In the 70s and 80s, AI research began to shift away from symbolic AI and started using statistical methods and mathematical models to solve problems. This shift was driven in part because symbolic AI was too complex, and in part by the development of new and improved computer hardware that made it possible to process large amounts of data quickly. In the 90s and 2000s, AI research continued to evolve, and new subfields began to emerge. One of these was machine learning, which focuses on creating algorithms that allow computers to learn from data without being explicitly programmed. Another was neural networks, which are mathematical models, but inspired by the structure and function of the human brain. Overall, AI has come a long way since its inception in the 50s, and it continues to evolve and improve at a rapid pace today. Generative AI is a subfield of AI that focuses on creating systems that can generate new, original examples, such as images, text, or speech, that are like examples from a given dataset, but not exactly the same. Generative AI sits on top of other areas of AI, like unsupervised learning, supervised learning, and reinforcement learning. It relies on the capability of those models to extract useful features from the data and has the potential to be used in a wide range of applications, such as computer vision, natural language process, speech recognition, and many more. When it comes to the Azure OpenAI service, the first step is to provision an Azure OpenAI resource in your Azure subscription. Azure OpenAI service is currently in limited access. Users need to apply for service access at the aka.ms/OAI apply. The approval time depends on several factors that can be difficult to calculate and can take a few business days. So make sure you make the request in advance of any plans you have to use the service. Once you have access to Azure OpenAI service, you can get started by creating a resource in the Azure portal or the Azure command line interface. The Azure OpenAI service provides access to many types of models, but certain models are only available in select regions. Before you get started, consult the Azure OpenAI model availability documentation for region availability. When you create an Azure OpenAI service resource, you need to provide a subscription name, resource group name, region, and select a pricing tier. As soon as that deployment is completed, you can start using the service. The Azure OpenAI service provides a studio, which is a web-based portal in which you can manage the models and deployments. You can access it from the resource page in the Azure portal or directly at oai.azure.com. The Azure OpenAI Studio will help you manage everything from deploying models to using your own data to testing the service. It also includes a few visual playgrounds, as we call them, for completions, chat, and DALL-E. What do you say? Let's go to a quick demonstration to see how to deploy and work with the service. So in order to use the Azure OpenAI service, we need to have an Azure subscription, an active one, and we need to have request access to the service and be approved for it. After we have completed all those steps, we can go to Azure and deploy a resource to work with it. In order to deploy a resource in Azure, we have to go to portal.azure.com, and this is the main page we would see. Here on the top, we can search for OpenAI and open the Azure OpenAI service. We can see all Azure AI services here, and on that tab, the ones I have created for Azure OpenAI. As you can see, we have more than one, and that can be used for several purposes. Maybe we have different models per region, or maybe we want to increase the availability of each model. There's a lot of ways to do that, so if you want, you can definitely create more than one. To create a new resource, we can click on the Create button, and this will take us to the Create Azure OpenAI form. Here, all we have to do is fill in the project and instance details. We need a subscription and a resource group. I'm using an existing one, the OpenAI. Under Instance Details, we can choose of the region. The region is the data center where our resource, our service is going to be deployed. This is where our data are going to be. And usually, we choose the one nearest to us or nearest to our customers. For this purpose, I will choose the Sweden. So Sweden Central here on the list, and provide a unique name. So for the name, I will go with OpenAI Sweden GK to make sure it's unique, and then choose a pricing tier. For this one, we only have standard S0. On the bottom, you can review the content policy and find more about filters and the code of contact. Now, these are the basic details you need to fill in. You don't need to do the rest. But if you want to, feel free to click Next. And if you have existing infrastructure, for example, you can set it up here. If you don't, you click Next, add your tags, or simply just go to Review and Submit. Review the information you have, and then just simply click to create the service. Now we have initialized the deployment. This will take us to the deployment page. We can continue working with Azure and other services while this gets deployed just fine. But if you're just intending to use this specific resource and the Azure OpenAI Studio, you need to wait until this process is completed. Now that the deployment is completed, you can go to the resource. If you haven't closed out this page, you can click this button, Go to Resource, and get to your created and deployed Azure OpenAI resource. On the top, you can see some essentials like the pricing tier, the API kinds, the location. And on the left, you can find other information like keys, endpoint, networking, and more. These are most of these options that most Azure resources have. Now back on the overview page, if we're ready, we can get started with the Azure OpenAI Studio. To find the Azure OpenAI Studio, make sure you go under the Overview tab in Displayed and find the Explore and Deploy. Here, under the Overview, as I said, you can click to go to the Azure OpenAI Studio. This is the main page of the Azure OpenAI Studio. On the top, there's a blue bar where we can see several options. On the top right, for example, we can see our username and which resource we're using. So as we saw, we might have more than one resource. We don't have to go back to the Azure portal to switch between them. We can just come here and click the Switch button. To switch between resources, we can also click the Settings. The first tab is the directory, the Microsoft Entra ID directory, and the second is the resource. Here you see which one it was chosen for me. It was the last one I've used, but we can always switch to another one, this one, for example. Then click Use Resource. It's going to reinitialize the OpenAI Studio to use this new resource. We can also use the settings to create a new resource from here. Again, we're going Settings, Resource, and in this page, find the Create a New Resource button here. Under the General tab, you can also change the language of the Azure OpenAI Studio. Now, there are several languages available beyond English, so if your language is here, feel free to use it. Now, near the settings icon, we have the bell icon, where we can get notifications and dismiss them if we don't want to see them again. Then we have the help under the question mark, where we can get documentation and links, and the feedback button. This button only is for general feedback. It's not for requesting help or anything like that. Something like, hey, I love the colors, or I'm recommending this, or I'm not recommending this. If you really require assistance, go back to the Azure portal and file a ticket so you can get support. Now let's close out this feedback and get back to the main page of the Azure OpenAI service. On the left, we have the icon to go back, and then we have the three playgrounds, which we can use from the main page or on the menu on the left. We have the chat for chat scenarios, the completions for completions, and the DALL-E to generate images. These are exactly like the APIs available. Under Management, we can find the models we have available, and here we can see the different families and which ones I have deployed, or can be deployed. Under the models, we have the data files, and here we can find testing and training dataset to customize our base models. This is what fine-tuning is, and this is where you would upload the data. Under quotas, right under data files, we can find the usage of our models. As you can see here, for 2 of those models, I'm using one at 100% and the other one just 4%. So this is the way I'm splitting my usage to be more efficient. On the right of this page, you're going to see a column called request quota. So if your usage is too little for your scenario and you want to request more, feel free to click on this button and request more tokens, more usage for your specific model that you require. The last option under management is content filters. The Azure OpenAI service includes a content management system that works alongside those models to filter the content. You create a content filter configuration, and this configuration can be assigned to a model deployment. So let's see how that looks. If I create a custom filter, essentially what I do is I take that prompt or completion and I filter how content that is inappropriate I want to get out. So there are different categories, either for the prompt or the response I get. And I can tweak those sliders. So this is it. This was Azure OpenAI Studio in a nutshell. I hope you enjoyed the demo. At this point, you might be wondering, why use Azure over the OpenAI APIs? So before we conclude this video, let's talk about it. The Azure OpenAI service gives us advanced language AI with OpenAI models, but with the security and enterprise promise of Azure. Azure OpenAI co-develops the APIs with OpenAI, ensuring compatibility and that we have a very smooth transition from one to another if necessary. But with Azure OpenAI, you get the security capabilities of Microsoft Azure while running the same models as OpenAI. Azure OpenAI offers, for example, private networking, and you can integrate your endpoints with your existing Azure infrastructure, or any other Azure service for that matter. You can choose the location of your data processing and storage for training data, which can improve security and compliance. The service also incorporates Microsoft responsible AI practices, such as content filtering. So as you can see, there are a lot of benefits in using the Azure OpenAI service. That was everything we needed to know about how to use the Azure OpenAI service to build generative AI solutions. Here, you learned what generative AI is, how to create an Azure OpenAI service resource, and use the Azure OpenAI Studio. So what are you waiting for? Request access to the service and start working with your models to build generative AI solutions right away. See you next time. Hi there, and welcome. In this video, you will learn how to deploy and test generative AI models. Knowing how to deploy an Azure OpenAI resource and working with the Azure OpenAI Studio portal will help you get the most out of this video, as we'll dive straight into how to deploy and interact with different models in the service. By the end of this video, you'll be able to understand the different types of Azure OpenAI-based models and how to work with the service and get results by using prompts and parameters. GPT means Generative Pre-trained Transformer, which is a language model that can generate human-like text based on a large dataset of text. To begin building with Azure OpenAI, you need to choose a base model and deploy it in the service. Then you can send prompts to the model and receive what we call completions, or results. Microsoft provides base models and the option to create customized base module. For the base models, there are several model families to choose from. GPT-4 models, for example, are the latest generation of models that can generate natural language and code completions based on natural language prompts. They are generally the best choice for all language and code generation tasks. GPT 3.5 models can also generate natural language and code completions based on natural prompts, In particular, GPT 3.5 Turbo models are optimized for chat-based interactions and work well in most generative AI scenarios. Embeddings models use a specialized form of data encoding for text to optimize specific tasks. We have three types of tasks: models that evaluate text for similarities, for searching text, and for searching code. DALL-E models are the most creative ones in my opinion, as they are used to generate original images based on natural language prompts. Choosing a model can be a complex task. Models differ by speed, cost, and how well they complete specific tasks. Older models are less complex than newer ones because they're smaller and consist of fewer layers. The right choice for a specific task depends on a balance of the speed at which the model can perform and how sophisticated their responses need to be. For example, smaller models tend to be faster, but larger models tend to be more capable. So it's up to you to find the one more attuned to your scenario. Azure OpenAI processes text by breaking down into tokens. These tokens can be words or just chunks of characters. For example, the word hamburger gets broken up into the tokens ham, bur, and gur, while a short and common word like pear is a single token. Many tokens start with a white space, for example, hello or bye. The total number of tokens processed in a given request depends on the length of your input, output, and request parameters. The quantity of those tokens will also affect the response latency and throughput of your models. Another consideration when designing your solution is the fact that the service evolves and new models become available every day. Some might be restricted, where you might wait to get access or still in preview. Additionally, certain models are only available in select regions, so make sure to consult the Azure OpenAI model availability documentation for region availability or model availability in general. Let's see how to work with different models. You first need to deploy a model to make API calls and receive completions to prompts. When you create a new deployment, you need to indicate which base model to deploy. You can deploy any number of deployments in one or maybe multiple OpenAI resources at the same time. This depends on your subscription quota, which you can see at the portal. You can deploy the models through the Azure portal or the command line interface, or CLI. After deploying the desired model, the core way to interact with the model in Azure OpenAI is to provide a natural language prompt as input. Models then respond with a completion. The completion depends on a number of factors, including the text in the prompt, the way the prompt is presented, which includes any prompt engineering techniques applied, and the parameters that are set from the interaction. Let's review the different tasks to get completions from models. We can use the service to classify content, for example, by providing a tweet, "I enjoyed the training course," and leaving the sentiment empty. This way, we will get the sentiment of these tweets, which is, in this case, positive. We can generate new original content by instructing the service to generate a poem about anything, like databases. We can transform or translate text from different languages and summarize long text content. We can use the service to continue our sentence and get some inspiration, for example. One way to grow tomatoes is to start with seeds. Or simply just ask a question, like, how many moons does Earth have? That will be answered with, Earth has one moon. Chat is a more advanced scenario that is supported by more recent models, in which a setup statement is used to define the chat context, and then the interaction consists of what we call turns, in which the user submits a message, the model returns responses, and so on. That sequence can provide with a variety of different results based on multiple factors, like the prompt, the context, and the history. To test this functionality, Azure OpenAI Studio includes multiple playgrounds for specific types of models. For natural language generation models, the available playgrounds are the completions playground, used for content generation tasks with GPT-3 family models, and the chat playground, again used for chat interactions with GPT 3.5 Turbo and later models. But before we go and see how to work with each playground, let's talk about parameters. The service enables you to enter prompts and to set parameters that control the completion returned by the model. When using the completions playground, you can set the following parameters, as we can see. Let's start talking about temperature. This parameter controls randomness. Lowering the temperature means that the model produces more repetitive and deterministic responses. Increasing the temperature, though, results in more unexpected or creative responses. There is a similar parameter called top P, but be careful, try adjusting either one or the other, but not both. Then we have the max length, which sets a limit on the number of tokens per model response. The API has a maximum of tokens shared between the prompt, including anything like system message, examples, message history, and user query, and the model's response. One token is roughly 4 characters for typical English text, but might be less if you're using a different alphabet. Stop sequences. This parameter makes responses stop at a desired point, which could be the end of a sentence or list. You can specify up to 4, while the model will stop generating tokens in response. The return text won't contain the stop sequence, if you're worried. Now let's talk about the top P, or top probabilities. It's similar to temperature, which controls randomness, but it does it with a different method. Lowering the top P narrows the model's token selection, and it uses likelier tokens. The result is the same. Increasing the top P lets the model choose from tokens that will make the response more creative, and lessening it will go the other way around. As previously mentioned, try adjusting either the temperature or the top P, but not both. Then we have the frequency penalty. This one reduces the chance of repeating a token based on how often it has appeared in the text so far. So it is less likely that we get the exact same text in a response, even though the context may be, the same. Then we have the presence penalty. It reduces the chance of repeating any token. This makes it more likely to introduce new topics in a response. Then we have the pre-response text. It will insert text after the user's input, but before the model's response. So we can help prepare the model for response. Or we can use the post-response text. Insert text after the model's generated response, but before it goes back to the user to encourage further user input, as when we're modeling a conversation. When using the chat playground, you can customize the setup description to set the context, and also set the following parameters, as we can see on the right of this slide. Some of these parameters we already explained, so let's just focus on the most important ones that are specific to chat completions. We have the max response, which sets a limit on the number of tokens per model response. As we said, the API has a maximum tokens shared between the prompt, including anything from system message, examples, history, and more, and the model's response. One token is roughly 4 characters or less for if it's not English texts, so be aware of how you use this. Then we have the top P, again similar to temperature, which controls randomness. So lower top P, less creative results, higher top P, more creative results. Try adjusting either temperature or the top P, as we said previously. There's another parameter which you will find only for the chat playground under the deployment settings, which is the past messages included. Select the number of past messages to include in each new API request. Including past messages helps us give the model context for new user queries. For example, setting this number to 10 will include 5 user queries and 5 system responses. Let's see a demonstration of using prompts and parameters to get completions. So this is the main page of the Azure OpenAI service. Here we can manage our model deployments, upload files, and view the playgrounds. In this demo, we'll talk about how to deploy a model and use the playgrounds. Once you deploy a model, then it's available for usage, either by the studio or the APIs. There are two ways of deploying a model. You can do this under management, either via models or via the deployments menu. Let's start with the models menu. In this menu, you can see all the available models that you have for this resource and their versions. So there are text models, GPT 3.5 models, and all you have to do to deploy a model is make a choice and click the deploy button, and you get to this deployment screen. There's another way to get to this deployment screen, and this is under deployments. Under deployments, you can see the models you have deployed, and from the top, you can create a new deployment. Here you can select a model from the available ones. So I'm going to go with this one, and then choose the available version. Now this little drop-down might not be available in all regions, so if it's not available to you, don't worry, it will be updated soon. The other thing we need to do is provide that deployment with a name. What I like to do is usually get the model, maybe a description on its functionality or usage, but feel free to put any name you want. After this, you can click on the advanced options and see more options available for the deployment. In the advanced options, we have content filters that we have pre-created in the other menu, and we can choose it here or change the tokens per minute rate so that we rate the tokens for this model so it can be utilized by other models in the subscription. So as soon as we're done, we click Create, and then the deployment finishes quite quickly. Now, after this, we are ready to play around with the APIs and models. We can always edit the deployment and change the version and the advanced options. I'm not going to make any changes, so I'm going to just cancel and go back. You can always remove a model and delete a deployment that you're not using. And then you can change the column options to change the information you see in this table. You can click refresh if you have deployed a model and it's not visible. And the next step is to go and test these models in the playgrounds. I'm going to start with a chat playground. This playground has three sections: the assistant setup, the chat session, and the configuration. The first is the system message. Here, you can select a template or simply type in a system message like we have here. For example, you are an AI assistant that helps people find information. Under this, you can add multiple examples to simulate a chat session between the user and the assistant. After you're done with the settings, you can go to the chat session and type something that you want to find out. For example, I am going to type, "Tell me some historic information about New York," and press enter. And as you can see, the chat provides with a lot of information, some of which are landmarks, some are from New York, Native Americans' history, and so on. You can clear the chat to reinitialize it, change the settings, or view the code that was used to create this interaction. As you can see, there's a lot of response. Under configuration, you can change the deployment model here if you have more than one, as I have here, or the past messages included right underneath. And here you can see the token count that you've used. Otherwise, you can change any parameter under the Parameters tab, as we can see here. So the next playground we're going to work with would be the completions playground. We can access it from the menu on the left. Here, we also need to choose a deployment model that we have deployed previously, and we do so by the top under deployments. You can have more than one deployed, but choose the one you want to use. Choosing this one, and then I'm going to load an example for you. I'm going to use the generate an email example. There's a lot more to get inspired from if you want to. This reads, write a product launch email for new headphones, and so on. And this is the instructions provided. Let's click generate to get the completions. As you can see, marked in green, here's the response from the model. We can always change the instruction, go back and regenerate the response by clicking the undo button or the regenerate button on the bottom. On the right, you can see the parameters you can change and get more probabilities, new responses, more creative ones, depending on what you want to do. The final playground we're going to see is the DALL-E. Here, it couldn't be easier. All you have to do is pass a sentence with the image you want and wait as the service creates that image for you. As you can see on the bottom of this page, these are all the created images we have so far. So these were the playgrounds and the model deployments for the Azure OpenAI Studio. This is how to use Azure OpenAI Service to deploy and interact with generative AI models by using prompts. In this video, you learned how to deploy an Azure OpenAI Service model and understand the types of Azure OpenAI based models available for your projects and generate completions to prompts. You can begin to manage model parameters such as temperature, frequency penalty, and presence penalty to control the quality and diversity of the generated text. Thank you for watching and keep unlocking the power of AI with the Azure OpenAI Service. Hi there, and welcome to the Get Started with Azure OpenAI Service Knowledge Check. This video is designed to help you test your knowledge on the basics of Azure OpenAI Service. I have included a series of questions throughout the video to help you test your understanding of the material. Now, these questions are designed to be interactive so you can have fun with learning. The way this will work is we'll go through the questions and I will give you the instructions to allow you some time to think about the answers or maybe note them down. Then we'll go through an explanation of the answers. Let's get started. For this quiz, we have 3 questions. Let's see how many out of 3 you can get. Let's start with question 1. What do you need in order to test a generative AI model using the Azure OpenAI Service Studio? 1. A deployed model name, an Azure command line interface? Or 2. An Azure OpenAI resource and an Azure Cognitive Services resource? Or maybe 3. An Azure OpenAI resource, a deployed model, and a playground? You can pause the video here and take some time to think about your answer before we move on to question 2. Now, for question 2, which parameter could you adjust to change the randomness of creativeness of completions? 1. Is it temperature? Or 2. Frequency penalty? 3. Stop sequence? Again, you can pause the video here and take some time to think about your answer before we move on to question 3. Finally, let's see question 3. Which Azure OpenAI Studio Playground is able to support conversational interactions that consist of a sequence of messages? 1. Completions, 2. Chat, or 3. Bot? Now pause the video here if you need to and take some time to think and make a note of your answers before we see the correct answers and their explanation. Are you ready? Let's see the answers. For question 1, to test a generative AI model using the Azure OpenAI Service Studio, we need an Azure OpenAI resource, a deployed model, and a playground. Cognitive Services resources have nothing to do with this question, and although we can use the command line interface to deploy models, we still need the OpenAI resource and playground to test the service. For question 2, the correct answer is temperature. Temperature is the variable that controls randomness or creativeness of completions. The frequency penalty parameter reduces the chance of repeating a token based on how often it has appeared in the text so far. So it is less likely that you will get the exact same text in a response. And the stop sequences parameter makes responses stop at a desired point, such as the end of a sentence or list. Finally, for question 3, the correct answer is chat. The chat playground is able to support conversational interactions that consist of a sequence of messages. Completions playground take only one prompt, and although Azure provides us with bot functionality, this is not part of Azure OpenAI. How many did you get? Well, if you didn't do well, don't worry. You can always go through the videos or use the learning paths in Microsoft Learn. I hope you enjoyed this interactive quiz, and thank you for watching. Stay tuned for more challenges. Hi there, and welcome. In this video, we will learn how to integrate Azure OpenAI into your application. To keep up with the topics of this video, you need to be familiar with the OpenAI Studio and the different model deployments. You will also need some basic coding knowledge in C# or Python. We will cover the different endpoints available to your application, such as text completion, text classification, and text summarization. And we'll see how to generate completions to prompts using the REST API and language-specific SDKs, specifically C# and Python. And we'll see some examples. By the end, you will have the skills to start building apps that leverage the Azure OpenAI service and unleash your creativity. To integrate Azure OpenAI into your application, you need to get the responses generated from the models. The way this works, applications submit the prompts to the deployed models, and responses are what we call completions. The Azure OpenAI service can be accessed via a REST API or an SDK currently available for Python and C#. There are 3 endpoints available for interacting with a deployed model, and they are used differently. Also keep in mind that certain endpoints can only be used by certain models. The available endpoints are completion, where the model takes an input prompt and generates one or more predicted completions. The second one is embeddings, where the model takes input and returns a vector representation of that input. Embeddings essentially measure how related 2 strings are. Chat completion is where the model takes input in the form of a chat conversation, where roles are specified with the message they sent, and the next chat completion is generated. The multiple REST endpoints reflect the evolution of OpenAI models. If you want to use the completion or embeddings endpoint for new application, you can just as well use the GPT-3 based models and later. For chat completion, you should use a GPT 3.5 Turbo or later model. Before making any requests, you need to ensure that you have an active Azure subscription and an Azure OpenAI resource created in the portal, and then you need to go and retrieve your endpoints and keys. You will need the model deployment name as well. The endpoint and key can be found on the Keys and Endpoints section in the Azure portal. The deployment name is the name you will provide when you deploy the model in the Azure OpenAI Studio. If you have all those values, you can integrate Azure OpenAI in any application. We'll see how to retrieve those values in the demo later. Once you have deployed that model in your Azure OpenAI resource, you can send a prompt to the service using a POST request to the corresponding endpoint. One of the endpoints is the completion endpoint, which generates the completion of your prompt. In this example, the prompt is, "Your favorite Shakespeare play is," and we also have the max tokens optional parameter. Completion endpoints allow for specifying other optional input parameters, such as temperature, max tokens, and more. If you'd like to include any of those parameters in your request, simply add them to the input data with the request. In the response, look for the choices array for the result. Here, you'll find the completion's text and more information. In our case, the completion of the prompt is Macbeth. The response object also contains information about the model, timestamp, and a unique identifier. The process is very similar to embeddings. Just remember to use the embeddings endpoint as seen in the top of this slide and choose a model meant for embeddings. These models you'll recognize because they start with text-embedding or text-similarity, depending on what functionality you are looking for. In the response, look for the data array. The vector information will be other embeddings. The chat completion endpoint requires a little bit more data when it comes to using the endpoints. Make sure to use the chat completions to differentiate from the completions endpoints. Now, OpenAI has trained the GPT 3.5 Turbo in later models to accept input formatted as a conversation, and this is how we need to provide it. The messages parameter takes an array of message objects with a conversation organized by role. Let's talk about how we supply the roles. There are 3 roles in the system: the user and the assistant. The system role, also known as the system message. This should be included at the beginning of the array. This message provides the initial instructions to the model. You can provide various information in the system role, including a brief description of the assistant, personality traits of the assistant, instructions or rules you want the assistant to follow, data or information needed for the model, such as relevant questions from an FAQ. You can customize that system role for your use case, or you can just include basic instructions. The system role/message is optional, but is recommended to at least include a basic one to get the best results. After the system role, you can include a series of messages between the user and the assistant. To trigger a response from the model, you should end with a user message, indicating that it's the assistant's turn to respond. You can also include a series of example messages between the user and the assistant as a way to do prompt engineering, called few-shot learning. Note that the input can include the previous messages in the conversation to provide additional context for the completion. To accomplish this, you can make a REST request in any programming language you choose, but there are SDKs available for Azure OpenAI in C# and Python. Let's see briefly how they work. The code we can see here shows sample C# code that uses the .NET SDK to call the getChatCompletions method for a GPT 3.5 Turbo or later model deployments. Note here that we need to initialize the OpenAI client with our endpoint and key. We also need the deployment model we retrieved, but we will provide it later in the code. Then, we need to prepare the prompt with as much detail as needed to get accurate responses. For the chat completion, that includes the roles, messages, and the parameters for the request. Then we get the response from the service, and we can iterate through the chat completion choices array to get the responses and present them to the user. After that, we can make subsequent requests for more information. A similar flow applies to the Python SDK. You configure the service settings that include your endpoint and key, and on the request, you set the deployment name and get a response. In the request, as usual, you can also add any parameters you want, and you look for the completion in the choices array. It does not matter whether you choose to write your own requests, but using the SDKs when available helps with faster and smoother integrations, as they simplify the process needed. Let's see a quick demonstration on how to find the keys and endpoint in the portal. So there are 2 ways to retrieve the endpoint and keys, and we're going to see both. The first way to retrieve the endpoint key and keys is via the Azure portal. To do that, we need to find the Azure OpenAI resource we have created and get it from there. So we can go to the top bar, write OpenAI, and go to our OpenAI resources. From this menu, we can choose the resource we want to. I'm using this one. And then on the left, under Resource Management, we can click on the keys and endpoints. As you can see here, you have two keys, the location and endpoint. There's always two keys in Azure for most services, and the reason is because we don't want to use any downtime. We can see the keys, copy the keys, or even regenerate the keys. And the way this works is usually an application is using one key, but then we want to regenerate it. Then what we do is switch the application to the second key, regenerate key 1, wait a little bit, like 10 minutes, to make sure the new key is active, and then switch the application back to key 1 and regenerate key 2. This way, we can guarantee there's no downtime for our applications that are using those keys. The second way to get those keys is to go to the Azure OpenAI Studio. Let's go to the second tab I have here and visit one of the playgrounds. As you can see, I have the same resource. And let's go to the chat. Gonna close the menu here to give me a little bit more space. And the first part is the assistant setup, where I put the system message and the examples of how the conversation should go. The second is the chat session, where I put my message, where I want the assistant to return responses. But on the top of this chat, as you can see, here's the query, and on the top, I have the View Code button. By clicking on that button, I can see different code samples for different languages. The first is the JSON. This is what we would send if we would make a REST request. And you can see there's code in Python and other languages like C#. On the bottom of those, you can see we have the information about the endpoint and keys. So we can copy them directly from here if we don't want to go back to the Azure portal while working with the Azure OpenAI Studio. Then you can take the code sample and use it as you wish. But if you remember, there's one more thing we need to call the services. And this is the deployment name, which we'll find under Deployments in the Management section, and the deployment name will be found in the leftmost column. That's about it. This is all the information we need to make REST requests or use the SDKs to the service.
I love this one.
That was a good one. Yeah. Woohoo! I'm taking a break. We just completed the topic how to build apps that integrate with the Azure OpenAI service. In this video, you learned how to differentiate between different endpoints available to your application, such as text completion, classification, search, and conversation, and how to generate completions to prompts using the REST API and language-specific SDKs, such as C# and Python. Now you're ready to start integrating your APIs through your application. Thank you for watching, and stay tuned to learn how to build the next generation of intelligent applications. Hi there, and welcome to the Build Natural Language Solutions with Azure OpenAI Service Knowledge Check. This video is designed to help you test your knowledge on how to integrate Azure OpenAI into your application. I have included a series of questions throughout the video to help you test your understanding of the material. These questions are designed to be interactive, so you can have fun while learning. The way this will work is, we'll go through the questions, and I will give you the instructions to allow you some time to think about the answers. Then we will go through an explanation of the answers. Let's get started. For this quiz, we have 3 questions. Let's see how many out of 3 you can get. Let's start with question 1. Which REST endpoints should you use to interact with a GPT-4 model? Completion, embeddings, or chat completion? You can pause the video here and take some time to think about your answer before we move on to question 2. Now for question 2. When using the .NET SDK, which method should you use to call the chat completion API? The chat message, the get chat completions, or the get completions method? Again, you can pause the video here and take some time to think about your answer before we move on to question 3. Finally, let's see question 3. When using the Python SDK, which method should you use to call the chat completions API? First, OpenAI.chatCompletion.get. Second, OpenAI.chatCompletion.create. Or third, OpenAI.chat.complete. Now, pause the video here if you need to and take some time to think and make a note of your answers before we see the correct answers and their explanation. Are you ready? Let's see the answers. For question 1, GPT-4 model currently support only chat completion. For question 2, the correct method to call the chat completion API from the C# SDK is the get chat completions. And finally, for question 3, the correct method to call the chat completion API from the Python SDK is OpenAI.chatCompletion.create. How many did you get? If you didn't do well, don't worry. You can always go through the videos or use the learning paths in Microsoft Learn. I hope you enjoyed this interactive quiz, and thank you for watching. Stay tuned for more challenges. Hi there, and welcome. Prompt engineering has become so crucial to generative AI, it has even become a professional role. And this is what we're going to focus on here. In this video, we will learn what prompt engineering is and how to design and optimize prompts for natural language processing models using the Azure OpenAI service. To get the most out of this video, you need to know how the Azure OpenAI service works, as we'll solely focus on prompt engineering techniques. By the end of this video, you'll have a better understanding of the concepts and role of prompt engineering in Azure OpenAI and how to get the best results possible. Large language models, or LLMs, are single models trained on huge amounts of data and can generate text, images, code, and creative content based on the most likely continuation of the prompt. The response quality from LLMs in Azure OpenAI depends on the quality of the prompt provided, what we call garbage in, garbage out. Improving prompt quality through various techniques is called prompt engineering. Designing effective prompts is critical to the success of prompt engineering, and it can significantly improve the AI model's performance on specific tasks. Providing relevant, specific, unambiguous, and well-structured prompts can help the model better understand the context and generate more accurate responses. We can also use them to specify the formatting and style of the completions, for example. If we want, for example, an OpenAI model to generate product descriptions, we can provide it with a detailed description that gives the features and benefits of the product. By providing this context, the model can generate more accurate and relevant product descriptions. In addition, prompt engineering can help us understand which references the model uses to generate its response. LLMs have a ton of parameters, and the logic it follows is largely unknown to users. So it can be confusing how it arrives at the response it gives. By designing prompts that are easy to understand, we can help users better know how the model is generating its responses. This can be particularly important in domains such as healthcare, where it's critical to understand how the model is making decisions. Prompt engineering can also help mitigate bias and improve fairness in AI models. By designing prompts that are diverse and inclusive, we can ensure that the model isn't biased towards a particular group or perspective. Remember though, no matter how good of a prompt you can design, responses from AI models should never be taken as fact or completely free from bias. Always use AI responsibly and check the responses you get for accuracy. Before exploring how prompt engineering can improve the output of Azure OpenAI models, it's important to consider how the different endpoints can utilize the methods discussed in this video. While both completions and chat completion can achieve similar results, chat completion provides the most flexibility in building your prompts and is optimized for chat scenarios. Functionally, chat completion has the option of defining a system message for the AI model, in addition to built-in structure to provide previous messages in the prompt. If using completion, this functionality can be achieved, but what is called a meta prompt. In terms of model availability, both endpoints can utilize similar models. It's worth noting that chat completion can also be used for non-chat scenarios, where any instructions are included in the system message and user content is provided in the user role message, as we see in this slide, where we have the same prompt delivered differently to the different endpoints. In the chat completion, we have split the first sentence as system prompt, "You are a professional events planner," and added the second part of the prompt, "Write an invitation for a party to celebrate the launch of a new product," to the user role, as opposed to a single prompt in the completions. And in addition to other techniques, adjusting parameters of the model can have a significant impact on the response. In particular, temperature and top P, which is top probability, are the most likely to impact the model's response, as they both control randomness in the model, but in different ways. Higher values produce more creative and random responses, but will likely be less consistent or focused. Responses that we want to be fictional or very unique benefit from higher values in those parameters, in case where we want to be very creative, whereas content desired to be more consistent and concrete or factual should use lower values. Try adjusting these parameters with the same prompt to see how they impact the response. It is recommended to change either the temperature or the top P, but not both. Asking the Azure OpenAI model clearly for what you want is one way to get desired results. By being as descriptive as possible, the model can generate a response that most closely matches what you're looking for. For example, say you want to create a product description for a new water bottle. Consider the answer associated with each prompt. If we go with a generic prompt like, "Write a product description for a new water bottle," versus, "Write a product description for a new water bottle that is 100% recycled, and include that it comes in natural colors with no dyes, and each purchase removes 10 pounds of plastic from our oceans." Including those specifics lets the model know what information to add to the description, making it more accurate to the new product. This method can be adapted to include complex instructions, such a bulleted list of details to include, the specific length of the response, or the desired formats to be included in the output. Try asking for exactly what you want to see in the result, and you may be surprised at how well the model satisfies your request. The way instructions are formatted can also impact how the model interprets the prompt. There is this thing called recency bias that can affect models, where information located towards the end of the prompt can have more influence on the output than information at the beginning. You may get better responses by repeating the instructions at the end of the prompt and assessing how that affects the generated response. This recency bias can also come into play when using chat completion in a chat scenario, where most recent messages in the conversation included in the prompt have a greater impact on the response. The next unit goes more in depth on using conversations to improve response quality by putting important information closer to the prompt may result in a better response. A specific technique for formatting instructions is to split the instructions at the beginning or the end of the prompt and have the user content contained within what we call section markers. These are blocks of dashes or sharp characters. These tags allow the model to more clearly differentiate between instruction and content. Including content for the model to use to respond, which allows it to answer with greater accuracy. This content got to be thought of in two ways: primary and supporting. Primary content refers to content that's the subject of the query, such a sentence to translate, or an article to summarize. This often is included at the beginning or the end of the prompt as an instruction and differentiated by blocks of symbols like dashes, as we said before, with instructions explaining what to do with it, as we can see in the first block here. For example, say we have a long article that we want to summarize. We could put it a section marker in the prompt and then end with instruction. Supporting content is content that may alter the response, but isn't the focus or subject of the prompt. Examples of supporting content include things like names, preferences, future date to include in the response, and so on. Providing supporting content, one, allows the model to respond more completely, accurately, and be more likely to include the desired information. For example, given a very long promotional email, the model is able to extract key information. If you then add supporting content to the prompt, specifying something specific you're looking for, the model can provide a more useful response. In this case, the email is the primary content with the specifics that you're interested in as the supporting content. Grounding content allows the model to provide reliable answers by providing content for the model to draw answers from. Grounding content could be an essay or an article that you then ask questions about, accompany a FAQ document, or any information that is more recent than the data the model has trained on. If you need more reliable and current responses, or you need to reference unpublished or specific information, grounding content is highly recommended. Grounding content differs from primary content as it's the source of information to answer the prompt query, instead of the content being operated on for things like summarization or translation. For example, when provided an unpublished research paper on the history of AI, it can then answer questions using that grounding content. This grounding data allows the model to give more accurate and informed answers that may not be part of the dataset it was trained on. For example, as we can see here, the first part would be the primary content the task applies to, the content to be summarized, to be translated, and so on. In the second section, we have any supporting content for clarification, and the last section has the grounding content, where the prompt will focus on the scope for the results. Another useful prompt technique are cues. Cues are leading words for the model to build upon, and often help shape the response in the right direction. They are often used with instructions, but not always. Cues are particularly helpful if prompting the model for code generation. For example, if you're wanting help creating a SQL query, provide instructions of what you need along with the beginning of the query. The model response picks up where the prompt left off, continuing in SQL, even though we never asked for a specific language. Other examples could be to help with Python code by giving code comments about the desired app and including import as a leading word at the end of the prompt, or something similar in your desired programming language. Another example, given a large collection of customer reviews in a prompt and ending with summarize the reviews above, most common complaints. The model then knows to complete the statement based off the context provided in the reviews and only summarize the complaints. Let's go see those techniques in action. To use prompt engineering, and we'll use the Azure OpenAI Studio and the Completions Playground for this demo. Remember that in order to use the playgrounds, you need to have deployed a model based on the functionality you want. To do that, you go under Deployment and create a new deployment. I have already a couple of models. I'm going to use this one so we can get started with the Completions Playground. Now, if this is the first time you're working with a service, feel free to use one of the examples. For me, it has already chosen the deployment I want, which is this one, and I can just get started. For our scenario, what I'm going to do is provide the service with one text article. It's part of a Microsoft article, and we're going to see with different prompts how we can get different results. Let's copy and paste this here. Okay, this is my article. And as with articles, the first thing we need to do usually is request a summary. So let's create a prompt to request a summary of this model. Provide a summary of the text below that captures its main idea. And then we click on Generate to see the results. Now, on the bottom, marked in green, this is the summary of the text. With a very quick reading, I can say that it does summarize a little bit of what the text outlines. This year marks a milestone with the development of AI, etc., etc. Now let's see how we can tweak this to get more specific results. Let's say that, for example, I want the summary, but I want it as a bulleted list. So the more instructions I give to the service, the better results I have. So here I'm going to write as a bulleted list. Let's remove this and try and generate again. Okay, so it did provide a summary and it did so in bullets. That's all well, but what if I want a specific part of the text? I want to know what the impact is of one of those new products, for example. The summary will help me figure this out, but it might be easier, for example, if I use section markers. Let's see how that will work. I can put some dashes here to kind of mark where the text is, where the article is. I'll remove this and provide instructions as a prompt. And I'll just put a simple question. What is the impact on the industry? Let's see how we can generate the results. So with a quick reading again, I see that it started with impact on the industry and then just the answer on this one. And we have a little bit of information on this. This is how we use section markers. But for this part, I only have just a little bit of text. But let's say I had code, I would probably use a different character, for example. So the way that we use section markers kind of changes based on our scenario. Now, something else I would like to see is how to work with queues. I love that this brings a summary on the article, but on top of this, I want to summarize the article, but I want to know first thing what those Microsoft products are. Because yes, it starts with a little bit of summary, mentions a couple of products here and there, but what is the main product? This is what I want to know. In this case, what I can do is this. I will remove this and provide a new prompt. So I want two things. I want to summarize the article, and this is the first one. And then I started with Microsoft product launched R, and just see if it's going to complete my sentence. We click Generate, and it worked. So it started completing my sentence with my cue that Microsoft product launched R, and we can see that it has the products mentioned in the text. Now, as you can see, we always need to check the responses because although Microsoft 365 was not part of the launch products, but it was the co-pilot for Microsoft 365, it still brought it up as a separate product. So make sure you always change your prompts, and check the accuracy of the responses. This is the way to work with basic prompt engineering in Azure OpenAI Studio. I hope you enjoyed this demo. Those were the basics of how to write more effective prompts for Azure OpenAI models. In this video, we'll learn about some techniques to optimize the performance of the models, such as providing clear instructions, using section markers to split the instructions, and the user content to help the model differentiate between them and process the prompt better by using primary, supporting, and grounding content. Finally, we talked about using cues. Prompt engineering involves several steps, and ultimately, no matter how well you design the prompt, the continuous testing and refining of the prompt will lead to the desired accuracy and relevancy. Thank you for watching, and keep unlocking the power of AI with the Azure OpenAI service. Hi there, and welcome. Prompt engineering is more than working with a single prompt to get a response. Providing the context is just as important to utilize its full potential. And this is what we'll focus on in this video. You'll learn to request output composition and use contextual content to improve the quality of the model's responses. To follow along with the concepts in this video, you need to be familiar with basic prompt engineering techniques like using queues and section markers, and of course the chat completion functionality of the Azure OpenAI service. By the end of this video, you'll be able to set the context, understand how the model interpreted the prompt, and ultimately increase the accuracy of the results. We will start by talking about structure. Specifying the structure of your output can have a large impact on your results. This could include something like asking the model to cite their sources, write the response in an email, format the response as a SQL query, classify sentiment into a specific structure, and so on. This technique can also be used with custom formats, such as a JSON structure. Here we can see a prompt that requests the response to be written as a table in Markdown with 6 animals in it, with their genus and species. And this is how the response looks. In chat completions, we have a huge advantage, as we have the opportunity to provide context by using roles. The system message is included at the beginning of a prompt and designed to give the model instructions, perspective to answer from, or other information helpful to guide the model's response. This system message might include tone or personality, topics that shouldn't be included, or specifics like formatting of how to answer. For example, you could give it this message: "You are a casual, helpful assistant. You will talk like an American old Western film character." And prompt the service with, "Can you direct me to the library?" You'll get this very entertaining response, which sounds a little bit like this in my head. "Well, howdy there, stranger. The library, huh? You'll just head down the main road till you hit the town square." And so on. You get my meaning. If using the completion's endpoint, similar functionality can be achieved by including the system message at the start of the prompt. This is called a meta prompt and serves as a base prompt for the rest of the content. System messages can significantly change the response, both in format and content. Try defining a clear system message for the model that explains exactly what kind of response you expect and what you do or don't want it to include. Along with the system message, other messages can be provided to the model to enhance the conversation. Conversation history enables the model to continue responding in a similar way, such as tone or formatting, and allow the user to reference the previous content in subsequent queries. This history can be provided in 2 ways: from an actual chat history or from a user-defined example conversation. Chat interfaces that use OpenAI models such as ChatGPT and the Chat Playground in Azure OpenAI Studio include conversation history automatically, which results in a richer, more meaningful conversation. In the parameter section below the chat window of the Azure OpenAI Studio Chat Playground, you can specify how many past messages you want included. Try reducing that to 1 or increasing it to the max to see how different amounts of history impact the conversation. Remember, more conversation history included in the prompt means a larger number of input tokens are used. You'll have to determine what the correct balance is for your use case, considering the token limit of the model you are using. Chat System can also utilize the summarization capabilities of the model to save on input tokens. An app can choose to summarize past messages and include that summary in the conversation history, then provide only the past couple of messages verbatim to the model. Using a user-defined example conversation is what is called few-shot learning, which provides the model with examples of how it should respond to a given query. These examples serve to train the model how to respond. For example, by providing the model with a couple of prompts and the expected response, it continues in the same pattern, without instructing it what to do. If the model is provided with just "you can't miss this," as we can see here, with no additional context from the few-shot learning, the response isn't likely to be useful and classified as positive or negative. Whereas by first providing the example that the prompt, "that was an awesome experience," with the user response as positive and "I won't do that again" as negative, the model has context helpful for it to respond and classify the responses as positive. In practical terms, conversation history and few-shot learning are sent to the model in the same way. Each user message and assistant response is a discrete message in the message object. The chat completion endpoint is optimized to include message history, regardless of if this message history is provided as few-shot learning or actual conversation history. While not ideal, similar results can be achieved with a completion endpoint by just including the conversation exchange within the single prompt, much like we saw with system messages. If you do need to include multiple messages in a single prompt with completion, you can make it clear to the model by putting each message on a new line and labeling each line with a row. Formatting this prompt would be similar to how the conversation was presented at the top of this section. Instructing the model how to respond is one thing. However, understanding the results is another. One useful method to help you break down the task effectively is to ask the model to explain its chain of thought. Asking a model to respond with a step-by-step process by which it determined the response is a helpful way to understand how the model is interpreting the prompt. By doing so, you can see where the model made an incorrect logical turn and better understand how to change your prompt to avoid that error. This technique can include asking it to cite its sources, like the Bing chat does, and giving reasoning for why it determined its answer. The chain of thought prompting techniques is best used to help you iterate and improve on your prompts to get the highest quality answer from the model. For example, asking the model, "what sport is easiest to learn but hardest to master?" results in a response with a, answer, and a small explanation of why. However, when prompted with, "what sport is easier to learn but hardest to master?" give a step-by-step approach of your thoughts, ending in your answer, the response is a complete explanation of how it arrived at its answer. Knowing the steps of reason the model used to form its response allows us to identify where we need to split the prompt maybe, or provide more information, or just clarify instructions. Let's try to combine all those techniques in the next demo. In this demo, we can see how to use prompt engineering to provide the context for this. I'm going to use the Azure OpenAI Studio and the chat playground. Now remember that before we do anything, either on the chat playground or the service itself and the rest of the playgrounds, we need to have a model deployment, so check if you have a model deployed for that purpose. To do that, you would go under Management and Deployments. As you can see here, I have these models, and this is the one I will be using for my demo. Let's go to work on the chat playground and provide history to our models. So I'm going to collapse the menu here, and as you can see, the chat playground has 3 sections: the assistant setup, the chat session, and the configuration. The ones that we're interested in, mostly for the context, is the assistant setup and the session settings on the right. Past messages are already included, up to 10 previous messages, so the playground already includes those for you. But if you're using the API, you might need to manually, every time you make a request, resend those previous history messages, or maybe a summary of them if you want to save on tokens. Now let's talk about the assistant setup. The first prompt engineering technique we can use to provide the chat completions, kind of a context, is called few-shot learning. This way, the assistant knows how to reply to the user with the same content, enthusiasm, accuracy, tone, or style. In the system message, we specify how the chat should act. And I'm actually going to use one of the pre-created ones. So I will go to the example dropdown and click on the marketing writing assistant. This fills up the system message with a lot of helpful information. So you're a marketing assistant, you help up with creative content, ideas, and so on. And this is where this writing style will be under. We also instruct it by saying, like, you write in a friendly tone, and if you don't know the answer to a question, respond by saying, I do not know the answer to your question. I'm going to add one example. This is what's called few-shot learning, and you can use either pre-created examples or previous chat messages. So I'm going to create one, but it helps if you create more than one. So I'm going to say, create a LinkedIn post as the user prompt for a book launch entitled Generative AI, and the assistant will respond, I am excited to announce that this new book is available, and the rest of the description for this. So the assistant sets the tone, and as we can see, it already provided a quick description, and this is what I want my posts or book descriptions or ads to be similar to. So we provide kind of a sample conversation. Remember to save changes on the top, because this will create a new chat session with all those new messages and new settings. Let's start chatting. So for this one, I'm going to instruct it to create a social media post for a magazine launch. And here is quite a lengthy post, actually. And we can see some little images and, drum roll please, a very exciting announcement that is in the style and tone of the system message and what I've provided. So there's a lot of things going on here. That wasn't exactly my vision for this post, so I can simply go back and change my prompt. But instead of doing this, I'm going to do something different. Instead of directly just changing my prompt and saying, hey, do something different, I am going to add to the prompt for this to give me a step-by-step approach of your thoughts ending in your answer. So I know how the model arrived at this answer, and then I can steer it towards the right direction. So I'm keeping the first part of the post, and then I'm adding the give a step-by-step approach prompt. Let's see how that works. The answer might take a little bit longer now to generate. And as I can see in the results, it actually broke down the way it thought about to answer in steps, and each step outlines how to start with a grab opening. The second is the announcement, and this is exciting announcement. Step 3 highlights the unique features. Step 4 creates a sense of exclusivity and urgency. Step 5 encourages engagement and excitement. So it's a comprehensive list of how it arrived at our results, and I love it. But I feel that it outlined so many categories, for example, in step 2, and this was the end result. What I wanted is to highlight the fashion aspects of this. So I'm going to take this again and just add focus on where to focus on. So I would say focus on the fashion aspects of the magazine. Let's see what the result on this would be. I'm also adding to add a specific hashtag. You can substitute company with the company name here so that, the post is a little bit more personalized. So let's hit it and see the results. Okay, let's go back and see the results. So I can see the company hashtag, so that works. Good. And additional fashion hashtags, so that's a good sign. And let's go up and see if it focused on the fashion aspects. And it did. It says for fashion-forward looks and styling tips and tutorials, outfits. So it did adapt based on my instruction. So this is a way to provide context within our prompts. Now, you can achieve a similar functionality for the completions endpoint, but then you would have to provide the whole context in a single prompt. So the chat kind of makes it a little bit easier to provide this with our prompts. I hope you enjoyed this demo on prompt engineering using context. We just finished prompt engineering context techniques with the Azure OpenAI service. In this video, you'll learn some best practices for creating clear instructions, requesting output composition, and using contextual content to improve the quality of the model's responses. Now you can engineer prompts like a pro. Try to remember though, not providing enough information is just as bad as providing too much information. When it comes to prompt engineering, it's important to strike a balance between being very specific and very broad in our descriptions. As with most things, which technique you might end up using is closely related to your individual scenario and goals. Thank you for watching and keep on learning. Hi there, and welcome to the Apply Prompt Engineering with Azure OpenAI Service Knowledge Check. This video is designed to help you test your knowledge on how to engineer prompts to get more accurate and relevant results with the Azure OpenAI service. I have included a series of questions throughout the video to help you test your understanding of the material. These questions are designed to be interactive so you can have fun while learning. The way this will work is we'll go through the questions and I will give you the instructions to allow you some time to think about the answers. Then we will go through an explanation of the answers. Let's get started. For this quiz, we have 3 questions. Let's see how many out of 3 you can get. Let's start with question 1. How can developers optimize the performance of Azure OpenAI models? By using complex instructions that are difficult to understand? By providing clear and descriptive instructions? Or by using vague prompts? You can pause the video here and take some time to think about your answer before we move on to question 2. Now, for question 2, what is the purpose of the system message in a prompt? To give the model instructions, perspective, or other information helpful to guide its response? To give the model a specific answer to generate? Or to provide filler information to the model? Again, feel free to pause the video here and take some time to think about your answer before we move on to question 3. Finally, let's see question 3. What is the purpose of providing conversation history to an AI model? Providing conversation history to an AI model is irrelevant and has no effect on the AI's performance. To limit the number of input tokens used by the model, or to enable the model to continue responding in a similar way and allow the user to reference previous content in subsequent queries. Now again, pause the video here if you need to and take some time to think and make a note of your answers before we see the correct answers and their explanation. Are you ready? Let's see the answers. For question 1, the correct answer on how developers can optimize the performance of Azure OpenAI models is by providing clear and descriptive instructions. Other techniques include adding section markers and cues. For question 2, the purpose of the system message in a prompt is to give the model instructions, perspective, or other information helpful to guide its response. And for question 3, the purpose of providing conversation history to an AI model is to enable the model to continue responding in a similar way and allow the user to reference previous content in subsequent queries. How many did you get? If you didn't do well, don't worry, you can always go through the videos or use the learning paths in Microsoft Learn. I hope you enjoyed this interactive quiz, and thank you for watching. Stay tuned for more challenges. Hi there, and welcome. Are you a software engineer who wants to learn how to use the Azure OpenAI service to generate and improve code? If so, this video is for you. You'll learn what the Azure OpenAI service is and how it can help you with your coding tasks, and explore the different features and capabilities of the Azure OpenAI service, such as code completion, code synthesis, code refactoring, and code documentation. To get the most out of this video, you will need some programming experience with C# or Python. Are you ready to get started? Let's dive into the Azure OpenAI service and see how it can help you generate and improve code. One of the capabilities of Azure OpenAI models is to generate code from natural language prompts. Tasks can range from a simple one-line command to a full application. The Codex models can also edit and update provided code or previous responses to complete the requested task. Most of the language models available can help with code, with some performing better than others. In the base GPT-3 family, the standard text models, such as the Text DaVinci and its versions, has a good base understanding of code. Codex and its models have expanded coding capabilities on top of the standard text model. As new generations of models evolve, the base models drastically improve their performance and understanding of both language and code, which results in not needing specific codex models. This improvement results in just a single model for most recent generations at least, such as GPT-3 3.5 Turbo and later, that can be used for both natural language and code completions. Azure OpenAI models can create functions and apps in several languages by just describing what you want. For example, say you need an implementation of a binary search, but can't remember how it's done. Given the prompt, "Write a function for binary search in Python," you likely receive a response with a function and an explanation of the code. The examples in this video are using GPT 3.5 Turbo. If you have code in one language but need it in another, Azure OpenAI can translate that for you. For example, say you have this print squares function in Python. If you provide that code along with a prompt, convert this code to C#, you will likely get something similar to the function we can see on the left. Notice the model understood the differences between how for loops and functions are defined in the different languages, including access modifiers in C#, and changed the code appropriately. Azure OpenAI models are helpful for understanding code that doesn't make sense, or maybe in a language you aren't familiar with. For example, say you were giving the following function, which is a fictitious coding language, by the way, and didn't know how to understand it. When provided to the model, along with a prompt, "Could you explain what this code is doing?" you get a response similar to the one we can see on the right. Combining the explanation and translation into a language you're familiar with makes this functionality even more useful. Azure OpenAI models are also capable of generating code based on comments, function names, and partially written code. The more context you can provide the model, the more accurate the response likely is. For example, when giving the following prompt, "Complete the following function," the model takes the comments and start of the function definition and completes it from whatever context it has. In this case, it was able to understand what we wanted due to a relatively simple and complete comment preceding the start of the function. With more complex functions or tasks, more context is required to get a useful response. It's important to note that for some languages like Python, the syntax is clear enough for the model to assume what language is desired. For syntactically similar languages like C# or Java, there's a higher likelihood that the model uses the wrong language. If that is the case, try specifying the language in the prompt or providing more code for context. Similar functionality can be seen by providing partial code to the model without any comments. The response likely also includes a natural language explanation of what that function is doing, or a few comments here and there. Tools such as GitHub Pilot utilize OpenAI models to suggest code and function completions in a similar way to the above examples. GitHub Copilot is an excellent example of real-world usage of this functionality that uses built-in prompts and the context of the code you're writing to act as your paired programmer. Azure OpenAI models can generate unit tests as well for functions you write to help make your code more robust. Unit tests are a type of software testing where individual units or components of a software are tested to determine whether they are fit for use. The purpose is to validate that each unit of the software code performs as expected. Unit tests isolate a section of code and verify its correctness. A unit may be an individual function, a method, a procedure, a module, or even an object. Take, for example, the binary search function. Provide that function along with a prompt, write 3 unit tests for this function, and you get a response similar to the following. This functionality is even more useful if you specify the cases you want included in your prompt, which reduces the time it takes for you to write unit tests for your code. To further improve your code, AI models can add comments and documentation for you, which is extremely time-consuming for developers otherwise. Azure OpenAI models can also help us fix bugs in code by analyzing the code and suggesting changes that can potentially fix the issue. This can help developers identify and resolve bugs faster and more efficiently. For example, suppose you have the following function, calculate average numbers, that isn't working for you. Provide that function to the model along with a prompt, fix the bugs in this function, and you get a response with a fixed code and an explanation of what was wrong. While the code, as developers write, may work, there might be a more efficient way to accomplish the task. Here's an example of a function that calculates the sum of the first n positive integers, possibly inefficiently, as it uses a for loop. This version works correctly, but its time complexity is bigger than what we want. When provided to the model, you can see the more efficient version that uses a mathematical formula. Better code is less prone to bugs and is easier to maintain, and the Azure OpenAI models can help guide developers on how to refactor their code. Instead of performance, we can also request the model to refactor the code to make it more modular and reusable, for example. But let's see some of these examples in action. So let's see how we can generate code with the Azure OpenAI Studio for this demo. We're going to use the chat playground, but you can just as well use the completions playground if you want to. You just have to structure your commands a little bit differently, that's all. Now, before we get started, as always, we need to make sure we have a deployed model. And to do this, we're going to Deployments under Management. I already have multiple models deployed, and this is the one I'm going to be using for this demo. Let's get started by using the chat playground. So I'm going to collapse the menu a little bit so we have a little bit more space to work with. And before I go into any setups or prompts, I am going to go to the configuration session and make sure that I have the correct model there. And I also limited the past messages to 1 because I'm not building an application that is related to each other. So I don't want previous messages to affect the results. But if you're building an algorithm or a bigger application and everything that you write and ask is related, feel free to include more of those past messages. Now let's go and work with the assistant setup. So for the assistant setup, I am not going to do a lot of setting up here, but I am going to put a system message, a simple one where you are an AI assistant that helps people generate code with no examples, and save changes. And now we are ready to start a chat session. The first thing we're going to do is put a little bit of code that does a binary search in Python and see how the service responds. With a quick look, it did bring up a binary search here. I can copy this, and as you can see, it's helpful that the code is in black, so I can, realize where it is. And on the bottom, we also get a little bit of an explanation, which is nice. So that was a good one. Let's go to the next one and provide the service some code where I'm going to ask the service to convert and explain what the code is doing. So let's see, convert the following code to C#. It's a small function, and as we saw, it did convert this to C#. With a very quick look, it looks correct. Of course, we'd always have to try it and see if it works. And it's great to see that it translated the function, it translated the for loop and everything that applies from one language to another, which is great. You also get a little bit of a description in the bottom, which is nice every time. So for the next one, I am going to provide the service some code and ask the service to explain what the code is doing. So let's bring that over. And this is a little bit bigger of a function. And just the prompt is, could you explain what this code is doing? That's it. Let's go and see the results. So fun fact here, the code I provided is actually a fictitious programming language. It doesn't exist. It looks like a programming language. But the response is actually correct. This is a pseudo language to calculate the Ackermann function. So that is great to kind of understand what code does without having to write or research it. So I'm clearing the chat in between to make sure there's no recency bias, but you don't have to do it every time if you're using a complete algorithm. Now for the next one, I'm asking the service to complete the following function. And I'm using section markers for this one. These are a little different than section markers that we're used to be using. They're not dashes or anything else, but they will work just as well because they note where a new section begins, and that's enough for the service to understand. And here we have two comments and just the start of a function in Python. Notice here that nowhere do I tell the service that I want this code in Python. And let's see if the service can find out and bring me the correct code. Response took a little bit of a while there, but from what I can see, this does look like Python code. So it works great. Now let's move on to the next one, which is writing unit tests. I'm going to clear that chat in between so it doesn't affect my answer. And bring in the next prompt. So we're asking the service to write 3 unit tests for this function, and this is a binary search function on the bottom. Let's see how the service responds to it. That was quick. Here are 3 unit tests for this function. And as we can see, we also get some comments and explanations, the array of numbers, which looks good to me. So it's a very good functionality if you want to speed up development and make sure we have accurate code. Now we have a couple more scenarios to go through. On the next one is to see whether the service can fix bugs or find errors in the code. So let's provide it with some code and see if the service can fix this. So just by looking at it, we can already identify some typos, but let's leave it up to the service to see if it can pick it up. So it did respond, and it actually found a couple of issues. So let's go up a little bit. So of course the typos, and it also saw that the variable average is not being calculated correctly. So good catch. And it does provide with the corrected code, which is great. Because then if we have to fix it and kind of find out, now we can just copy paste it and put it on our environment and run it very, very quickly. For the final one, I am going to ask the service to refactor code for me. So how can this function be improved? Refactor this in Python and provide the new code. This is my prompt, and then the function on the bottom. So the service realized that this function can be improved using a mathematical formula instead of a for loop, which was what I was using. So it turned this into just one line of code, which was great, and it helps with being efficient and probably with some execution time. So that is great. We also get an explanation, as always, in the bottom. And this is very exciting to see. Now, remember that refactoring doesn't have to be about just improving code. We can just make things more modular or just change the format a little bit so that our code is better. That was it. This was our demo for generating code. Feel free to use this service to do so, or use any of the other tools like GitHub Copilot, for example, which does show a similar functionality, but the great thing about it is that it does it while you type the code. So it's great. It's like having another programmer kind of guiding you through what to do. I hope you enjoyed this demo with code generation and Azure OpenAI. In this video, you have just learned how to use the Azure OpenAI service to generate and improve code. We covered how to construct code from natural language, complete and explain it, fix bugs, write documentation, improve the performance, and refactor the results. This functionality can benefit any level of programming experience. Beginners will learn new things and find out new ways to improve their code, and experienced developers will save a lot of time while working. And let's consider the number of languages available. As someone who has had to learn to code in more than a few languages to keep up professionally, ramping up my skills in a new programming language quickly is a game changer. Now everyone can be a great software engineer. Thank you for watching and happy coding! Hi there, and welcome to the Generate Code with Azure OpenAI Service Knowledge Check. This video is designed to help you test your knowledge on how to generate, explain, or fix code with the Azure OpenAI service. I have included a series of questions throughout the video to help you test your understanding of the material. These questions are designed to be interactive so you can have fun while learning. The way this will work is, we'll go through the questions and I will give you the instructions to allow you some time to think about the answers. Then we will go through an explanation of the answers. Let's get started. For this quiz, we have 3 questions. Let's see how many you can get. Let's start with question 1. What are some benefits of using Azure OpenAI to generate code? Increase efficiency and productivity? Increase in bugs and readability? Increase in time spent coding? You can pause the video here and take some time to think about your answer before we move on to question 2 if you want. Now for question 2. What is the purpose of providing more context to the Azure OpenAI model when completing partial code? Providing more context makes the model less accurate. Providing more context doesn't affect the accuracy of the model. The more context provided to the model, the more accurate the response likely is. Again, you can pause the video here and take some time to think about your answer before we move to the last question. Finally, let's see question 3. What is an example of how Azure OpenAI models can change coding language? Azure OpenAI models can only translate code from one language to another if the code is written in C#. If you have code in one language but need it in another, Azure OpenAI can translate that for you in several languages. Azure OpenAI models can only translate code from Python to C# or Java. Now pause the video here if you need to and take some time to think and make a note of your answers before we see the correct answers and their explanations. Are you ready? Let's see the answers. For question 1, the correct answer is to increase in efficiency and productivity. Of course, the service won't make you into a developer if you have no knowledge, but the capabilities of the service will save you time in coding, whether that is writing code from scratch or fixing bugs. For question 2, the correct answer is the most context provided to the model, the more accurate the response likely is. Although codex models work for code, the basic principles of prompt engineering still apply. And for question 3, the correct answer is, if you have code in one language but need it in another, Azure OpenAI can translate that for you in several languages, as long as you provide the proper prompts and instruct the service properly. So, how many did you get? If you didn't do well, don't worry. You can always go through the videos or use the learning paths in Microsoft Learn. I hope you enjoyed this interactive quiz and thank you for watching. Stay tuned for more challenges. Hi there, and welcome. In this video, you will learn how to use the amazing DALL-E model to generate original images based on natural language prompts. We will talk about the capabilities of the service and how to get the generated image. To keep up with the concepts in this video, you need to be familiar with the Azure OpenAI service and bring on your creativity. Some basic coding knowledge in C# or Python will also be helpful. By the end of this video, you'll be able to generate original images using your own creativity and natural language. If you are ready, let's go explore the capabilities of DALL-E together. DALL-E is a neural network-based model that can generate graphical data from natural language inputs. Put more simply, you can provide DALL-E with a description, and it can generate an appropriate image. For example, you might submit the following natural language prompt to DALL-E: a Highland cow in a field on the coast of Scotland, digital art style. This prompt could result in the generation of graphical output, such as the image we can see on the right. The images generated by DALL-E are original. They are not retrieved from a curated image catalog. In other words, DALL-E is not a search system for finding appropriate images. It is an artificial intelligence AI model that generates new images based on the data on which it was trained. To experiment with DALL-E, you can provision an Azure OpenAI service resource in an Azure subscription that has been approved for access to the service, and use either the DALL-E Playground or the APIs to submit prompts and view the resulting generated images. When using the Playground, you can adjust the settings to specify the number of images to be generated in a response to a prompt. The default is 1, but it can go up to 3 or 4, and the resolution of the generated images. Available sizes range from 256 to 1024 pixels. You can use the Azure OpenAI Service REST API to consume DALL-E models from applications. To make a REST call to the service, you need the endpoint and authorization key from the Azure OpenAI Service resource you have provisioned in Azure. You initiate the image generation process by submitting a POST request to the service endpoint with the key in the header. The request must contain the following parameters in a JSON body: the prompt, which is the description of the image to be generated, the end parameter, which is the number of images to be generated, and the size, which is the resolution of the images to be generated. For example, the following JSON could be used to generate a 512 via 512 image of a badger wearing a tuxedo. The result from the initial request does not immediately return the results of the image generation process. Instead, the response includes an operation location header with a URL for a callback service that your application code can poll until the results of image generation are ready. When the operation status returns succeeded, a response similar to the following JSON is returned. Look for the result element, which includes a collection of URL elements, each of which references a PNG image file generated from the prompt. In this example, the resulting file might look similar to this image we can see on the right. Before making any requests, you need to ensure that you have an Azure Active subscription and an Azure OpenAI resource created in the portal, and retrieve your endpoint and keys. The endpoint and key can be found on the Keys and Endpoints section in the Azure portal. You can make a REST request in any programming language you choose, but there are SDKs available for Azure OpenAI in C# and Python. Let's see briefly how they work. The code shows sample C# code that uses the .NET SDK to call the getImageGenerations method. Note that we need to initialize the OpenAI client with our endpoints and key to get the results. There is also an asynchronous method available. A very similar flow applies to the Python SDK. You configure the service settings that include your endpoint and key on the request, you set the prompt and parameters, and you get a response. The code calls the image.create method for a DALL-E. There's also an asynchronous method available here as well. Now what do you say? Let's go and use the Azure OpenAI Studio to generate some images. So for this demo, we're going to use the Azure OpenAI Studio and the DALL-E Playground. Remember that the only thing you need to get access to the DALL-E models is to have requested access via the form and gotten your subscription approved. As soon as you get that approval, you're able to see the DALL-E Playground in the main page of the Azure OpenAI Studio, and by clicking on that icon on the left that says DALL-E, you can use and generate images. Now, the DALL-E Playground is fairly simple. You have the prompt text box where you insert your prompt so that you can generate images, and then you can change some of the settings of the generation. To do that, you go into the Settings button, and it will get us this pop-up where you can change how many images you want to generate and the image resolution that you want. So there are a few sizes available. Changing these settings might change the time it takes to generate those images, but make sure you choose the one that works for your scenario. So I'm not going to make any changes here, so you can either click Save or Cancel depending on what you want to do, and go on with your prompts. Now let's see an example. Suppose I'm working on a product proposal for a new iced coffee, and I would really like some kind of coffee image to go with that proposal. Now I need to build a prompt and get that result. So the first thing I can get started with is this query. We're going to see this prompt, which is like, I want just a coffee on the table, something simple. I click Generate, and I get the results. The generation, depending on the settings we have, shouldn't take long. So this is what my prompt brings: a coffee on a wooden table, which is very, very nice, but not exactly what I had in mind. So my proposal is about iced coffee, and this is warm coffee. So let me just change my prompt and see how to get better results. So let's see the result with a prompt that has a little bit more details than the one I put. So in this prompt, I've explained exactly what I want and what my vision for the image is. So I want an iced coffee on a wooden table with a coffee house background next to my laptop while I'm working, because I want to take that remote work vibe within that proposal. So let's see what the service can generate by clicking the Generate button on the right. Again, the generation shouldn't take long. So this is what the service came up with, which looks very nice. I can see the coffee house, feel some kind of coziness while I'm working, and this is exactly the vision I have, and I will take that and include it in my proposal. For the same prompt though, if you want, you can come in to those buttons in the bottom and do a few things. You can copy the image, you can generate a new image by clicking this one. Of course, you can download the image with this button and use it in your application, documents, and more, or even show the code that was used to generate the image. So here on the sample code, I don't have many options. I only have the code in Python, but it's very helpful because all the values have been put in there, and all I have to do is copy this and put it in my code and generate those images. I have my endpoints and keys at the bottom as always, so I don't have to leave the page if I don't want to, and I can just simply write in Python. If I want to use another programming language and make a REST request, here is the JSON that was used to generate that image with a prompt, the n, which is the number of images, and the size of each image. So I can just take that and create images by making a post request to the service. Now this was the DALL-E demo by using the Azure OpenAI Studio. I hope you enjoyed this demo. And remember, the prompt engineering works just as well for DALL-E as the other models. You have just learned how to use the DALL-E model in the Azure OpenAI service and transform your words into art. There are a lot of things you can do, and you can generate your own images. You can use them as inspiration for your art, for example, or designs, or photography projects. You can make illustrations for your blog posts, articles, social media, or even just create visual aids for your presentations or videos. What are you waiting for? You're a few sentences away from unleashing your creativity. Thank you for watching, and keep on innovating. Welcome to the Generate Images with Azure OpenAI Service Knowledge Check. This video is designed to help you test your knowledge on how to generate images from the playground or code. I have included a series of questions throughout the video to help you test your understanding of the material. These questions are designed to be interactive, so you can have fun while learning. The way this will work is we will go through the questions, and I will give you the instructions to allow you some time to think about the answers. Then we will go through an explanation of the answers. Let's get started. For this quiz, we have 3 questions. Let's see how many out of 3 you can get. Let's start with an easy one. You want to use a model in Azure OpenAI to generate images. Which model should you use? DALL-E, GPT 3.5 Turbo, or Text DaVinci? You can pause the video here and take some time to think about your answer before we move on to question 2. Now for question 2. Which playground in Azure OpenAI Studio should you use to explore image generation? Completions, DALL-E, or Chat? Again, you can pause the video here and take some time to think about your answer before we move on to question 3. Finally, let's go to question 3. In an API request to generate images, what does the n parameter indicate? The description of the desired image, the number of images to be generated, or the size of the image to be generated? Now, pause the video here if you need to, and take some time to think and make a note of your answers before we see the correct answers and their explanation. Are you ready? Let's see the answers. For question 1, the correct answer is DALL-E, which is the name of the model and the playground. So as you can guess, this is also the correct answer for question 2. For question 3, the correct answer is that the n parameter indicates the number of images to be generated. The description will go to the prompt parameter and the image size to the size parameter. So, how many did you get? If you didn't do well, don't worry. You can always go through the videos or use learning paths in Microsoft Learn. I hope you enjoyed this interactive quiz, and thank you for watching. Stay tuned for more challenges. And welcome on this video, how to use Azure OpenAI with your data. Here, we will learn how to use the Azure OpenAI service to generate responses based on your own data sources, such as documents, websites, or databases. You'll also learn about the benefits and challenges of using generative AI with your own data. To get the most out of this video, you need to have a solid understanding of both Azure and the Azure OpenAI service. The content in this video also assumes that you are familiar with the basics of these services and will build upon your existing knowledge to help you use the Azure OpenAI service to generate responses based on your own data sources. By the end of this video, you will have a better understanding of how to use Azure OpenAI on your data to create engaging and informative chat experiences tailored to your scenario. Let's get started. Azure OpenAI on your data allows developers to use supported AI chat models that can reference specific sources of information to ground the response. Adding this information allows the model to reference both the specific data provided and its pre-trained knowledge to provide more effective responses. Azure OpenAI on your data utilizes the search ability of the Azure Cognitive Search service to add the relevant data chunks to the prompt. Azure Cognitive Search is a cloud service that allows developers to create powerful search experiences over diverse content in web, mobile, and enterprise applications. It offers rich indexing, flexible querying, scalability, and security. What this service essentially does is provide a search engine for full text and vector search over a search index you create. You can enhance indexing through cognitive skills that incorporate other AI services. For example, when you create the index, if there are images in the content, you can enrich the search space by using optical character recognition to get that data. In essence, Azure Cognitive Search is like having a smart librarian who quickly finds the right information for you. The goal is to get your data, upload them to the service, and create an index the search service can use to find information fast. Once your data is in a cognitive search index, Azure OpenAI goes through the following steps. Azure OpenAI receives the user prompt and then determines relevant content and intent of the prompt. The next step is to query the search index with that content and intent. The service inserts the search result chunk into the Azure OpenAI prompt along with the system message and user prompt. Finally, it sends the entire prompt to Azure OpenAI and returns the response and any data reference to the user. The result is the combined functionality of the two services together. The process is fairly straightforward. We need to set up a data source, then configure the studio to use our own data, and finally use the models as usual to get results. Although this time, the results will be grounded on our data. There are several different sources of data that you can use. These sources will be connected to the Azure AI Search, to blobs in an Azure storage container that you provide, or any other local files uploaded using the Azure OpenAI Studio. You can additionally ingest your data from an existing Azure AI Search service or the Azure Cosmos DB for Mongo, for example. Fine-tuning is a technique used to create a custom model by training an existing foundational model, such as GPT 3.5 Turbo, with a dataset of additional training data. Fine-tuning can result in higher quality requests that prompt engineering alone cannot achieve. It customizes the base model on examples larger that can fit in a prompt and allows the user to provide fewer examples to get the same high-quality response. However, the process for fine-tuning is both costly and time-intensive and should only be used for use cases where it's necessary. Azure OpenAI on your data still uses the stateless API to connect to the model, which removes the requirement of training a custom model with your data and simplifies the interaction with the AI model. Cognitive Search first finds the useful information to answer the prompt, and then Azure OpenAI forms the response based on that information. By default, Azure OpenAI in your data encourages but doesn't require the model to respond only using your data. This setting can be unselected when connecting your data, which may result in the model choosing to use its own pre-trained model knowledge over your data. You need to remember that by using your own data, you are using at least two additional services, one to host the data and the Azure Cognitive Search service. Each service in Azure comes with its own pricing model, usage capabilities, and limitations, so make sure you know what these are when you're designing your solution. Adding your data is done through the Azure AI Studio in the chat playground. The data source you add is then used to augment the prompt sent to the model. When adding your data, you can choose to upload your data files, use data in a blob storage account, or connect to an existing cognitive search index. If you're uploading or using files already in a storage account, Azure OpenAI on your data supports specific formats, specifically MD, TXT, HTML, PDF, and Microsoft Word or PowerPoint files. If any of these files contain graphics or images, the response quality depends on how well text can be extracted from that visual content. There is an upload limit, and there are some caveats about document structure and how it might affect the quality, but you don't have to worry about that too much. When uploading data and connecting to files in a storage account, it's recommended to use the Azure AI Studio to create the search resource and index. Adding data this way allows the appropriate chunking to happen when inserting into the index, bringing us better responses. When creating the index, you'll also get the option to use an embeddings model to create a vector if you want to improve your results. Additionally, enabling semantic search for your cognitive search service can improve the result of searching your data index, and you're likely to receive higher quality responses and citations. However, enabling semantic search may increase the cost of the search service. Since Azure OpenAI on your data includes search results on your index in the prompt, it's important to understand how that impacts your token allotment. Each call to the model includes tokens for the system message, the user prompt, conversation history, retrieved search documents, internal prompts, and the model's response. The system message, for example, is a useful reference for instructions for the model, and it's included with every call. While there's no token limit for the system message, when you're using your own data, the system message gets truncated if it exceeds specific tokens. The response model is also limited when using your own data. Look out for those limits and proceed accordingly. Due to these token limits, it's recommended that you limit both the question length and the conversation history length in your call. Prompt engineering techniques, such as breaking down the task and chain of thought prompting, can help the model respond more effectively. The call when using your own data needs to be sent to a different endpoint than it is used when calling a base model, which includes the path extensions. Your call will be sent to a URL similar to the one we can see on the top of the slide. To use the API with your own data, you need to specify the data source where your data is stored. With each call, you need to include the endpoint key and index name for your cognitive search resource. The request will also need to include the content type and API key. You will need to include the messages array and any other parameter as usual. Your request body will be similar to the JSON we can see on the right. You can make a REST request in any programming language you choose, but there are SDKs available for Azure OpenAI in C# and Python. Let's see briefly how they work. The code shows sample C# code that uses the .NET SDK to call the getChatCompletions method. Note that we need to initialize the OpenAI client with our endpoint and key as usual, but now, in addition to the messages array, we need to provide the Azure Extensions options. That includes the keys for your cognitive search resource. We also need the deployment model to make the request. A very similar flow applies to the Python SDK. All we need is to declare the data sources array in addition to the other objects and send the request. Now let's go to a demo on how to deploy the additional services needed and use the Azure OpenAI service with our own data. So for this demo, we're going to be using the Azure OpenAI Studio. This is the homepage of the studio. And for this demo, we'll use the chat playground to run it. Now here, we will see how the model works before we ground it with our own data and after we add some data. The data we're going to use with the service are specific travel brochures from a travel agency. And we want to see what information the model provides without any data about a destination like New York, and what kind of information will it provide by pulling that information from our documents. So before we get started, I want to remind everyone that in order to use the playgrounds, we need to have a model deployment. So if you don't, go under the Management, Deployment, and create a new deployment. We need a GPT 3.5 model, turbo, and later to do this. So for this purpose, I'm going to be using this one. You can use this or a later one if you want for your scenario. Now to load our files, we'll need to go to the chat playground. So let's collapse the menu so I have a little bit of space. And then we need to set up the assistant. I'm not going to do anything specific here. I'm just going to use the default template and leave all the other options out to focus on our own data. So this is just an AI assistant that helps people find information. Let's go to the chat session and see how the model responds without any data. So I'm going to ask it, I'd like a trip to New York, where should I stay? And this is a lengthy response. But if you look a little bit closely, the response just brings us a lot of neighborhoods in New York City. No hotels or something specific, just different neighborhoods like Manhattan or Brooklyn. So we can keep asking the model to create some kind of baseline normal chat behavior. So let's ask it what some facts are, for example, about New York again. And here we get some facts. With a very quick, brief look, I saw a couple of landmarks, the residence, Statue of Liberty, etc. So now, let's upload our data and see how that changes the results. To upload our own data, we need to go through the Add Your Data tab under the Assistant Setup and add a data source. The data we're going to upload are these kinds of brochures, like the one we see now, where we have some information and fun facts about New York, and on the bottom we have a few New York hotels. So this is the information we have. So let's go back and upload this and a few other documents in the service. So we need to go to the Add Your Data and click to create a data source. So let's see how to select or add a data source. Now the data source, as we talked about previously, needs to be an external service. We can use an existing one, like we can see here, or we can simply go to the bottom to upload our own files. And here we're taken to a page to choose the two additional services, the blob storage that will host our files and the AI search that will help us search and ground our data. Now, of course, we can use an existing one, but it's better to create one via the service if you don't have one, by clicking that button on the bottom underneath, which will take us to the Azure portal. It opens a new tab for us in the Azure portal and takes us directly in the Create form for the storage account. We'll need to fill out this form to deploy this new service. So, as always, we need to choose a subscription and resource group to put some basic information in. For the resource group, I'm going to use an existing one I called OpenAI. And then we have to fill in some instance details. We need to put a unique name, so I'm going to use this one. I have already created, so for the sake of this demo, I'll use the pre-created one. So I'll just put a 2 there to differentiate, but this is the name I need to keep for my service. And then we choose the data center. Here, make sure you choose the same region the resource you have in the OpenAI Studio is. So the one I have is in East US, so I'm going to choose the same region here. So the region needs to be the same for all those services. You don't need to change the performance, the standard is okay, and for the redundancy, I chose the most cost-effective option. These are the basic information we need. There are some tabs here, but I'm going to skip through this, go to the review page, and create that service. It reviews, does a validation that the basics and information I have put are correct, and all I can do is create the service by clicking that button. Then we can go back to the OpenAI, click on the drop-down, and choose the one you just have created. The second step is to do the exact same process for the Azure AI search resource. So I'm clicking on that link below the dropdown. It will take me again to the Azure portal and directly to create a search service screen. Again, here I have to put some basic information. I'll choose the same resource group. And then I'm going to choose a service name similar to the other one. So I'm going to put this one. Again, for the sake of the demo, I have pre-created this, but this is the process you would go through. You have to use the same region as all the other resources, so I have to find the East US one. And then I can change the pricing tier. I'm going to need a basic one for this. I don't need the features the standard provides. Click Select, and Review and Create this service. So you go to the Review and Create screen. Of course, we have a couple of more tabs here, but you don't have to put these, are optional. And after you're done, click on Create. And it will deploy the service. So for the sake of this demo, I'm going to use my own services because sometimes it will take a little bit longer to get those services. So I come back on this screen, and as you can see, I've chosen the ones I just created. For you, it might take 5-15 minutes, so if it doesn't show up exactly after the deployment, don't worry. Just take a little bit of time and refresh the page a couple of times until they show up in the list, okay? And this is how you would create those resources. After this, all we have to do, as soon as you've created everything and you have filled this form, you have to provide a name for the index. So I chose the name Travel Index, and on the bottom you can see a checkbox that says Add Vector Search to the search resource. If you choose to do this, you would have to deploy an embeddings model and include it here. I'm not going to go through this, but if you want embeddings, you can do that here as well. On the bottom, you have to acknowledge that it might have extra cost on top of the services you are using, and this is natural because it's a separate service and it has its own pricing model. Click Next to upload your files. So here, I'm going to upload my files. So these are the brochures I have for different destinations like London, like New York, and more. I'm going to upload all of them. And in this page on the bottom, you can click to upload the files when you're ready. And in this little table, there's a status that says pending, and they will change to uploaded. So these are just a few files, so the upload was very quick. As soon as the files have been uploaded, you can click Next. Then you can choose the search type. This is keyword, the only one we have. You can have different configuration, but we're going to choose keyboard for this one. Review the settings you have so far. If you're satisfied, save and close. And this will create an ingestion process, which has multiple steps. First, it uploads your data to the blob storage, then creates the index. As soon as the index has been created, then you can go ahead and start chatting with your own data. So the travel index was created and the process is complete. Now we are ready to use the service. So if you go to the chat session on the right, on the bottom, you will see that the chat has been reinitialized because now the service is going to use your data. Let's see now how the chat changes and the responses change when we ask the same questions as we did before, but now the service is going to use our own data to answer them. Let's see, so again, same question. I would like to take a trip to New York. Where should I stay? And if you remember previously, it provided us with areas and neighborhoods. Now let's see what the recommendations are. Okay, so now it actually suggests hotels, which is great because this is what the brochure has, specific hotels in different areas. And in the bottom, you can see there is how to visit, like a citation, where this information comes from. So let's try the second one to get information about the city and see how the response changes. What are some facts about New York? And if you remember in the brochure PDF on the top, there were some quick facts about the city. So as we can see, we get the population. We don't get this in a bulleted list, but like in a huge paragraph. And we also get some other content like the United Nations and how the city is described. Again, we get references where this data comes from, which is our own data. So that's great, the service works, and now instead of giving generic responses, we get information from files that we feed into the service. Now, in order to use that information from the code, you can always go to the View Code menu here and get that information. But don't forget, when it comes to using your own data, on top of the other information, you need the deployment ID for the model, the API keys as usual, but you also need to add the search endpoint and the search key, as well as the index name. And you can go to the bottom and find those values, or you can go to the resource in the Azure portal. But it's easier to get it from here, so you don't have to switch between different portals. So this was Azure OpenAI and using your own data. I hope you enjoyed this demo. We just saw how to use Azure OpenAI on your data. In this video, you learned how to use the Azure OpenAI API to generate responses based on your own data with the help of the Azure Cognitive Search Service. Now it's your turn. Find a few manuals or documents you have that you never got around to read through. Upload them to the service and see how effective it is to ask a question instead of looking through multiple pages for the answer. Thank you for watching and keep working on the next generation of intelligent applications. Welcome to the Use Your Own Data with Azure OpenAI Service Knowledge Check. This video is designed to help you test your knowledge on how to use your own data with the service. I have included a series of questions throughout the video to help you test your understanding of the material. These questions are designed to be interactive, so you can have fun while learning. The way this will work is we'll go through the questions and I will give you the instructions to allow you some time to think about the answers. Then we'll go through an explanation of each answer. Let's get started. For this quiz, we have 3 questions. Let's see how many out of 3 you can get. I'll start you with an easy one. What does Azure OpenAI on your data enable developers to do? Create their own AI chat models? Access Azure OpenAI without an approved subscription? Or use supported AI chat models that can reference specific sources of data? You could pause the video here if you'd like and take some time to think about your answer before we move on to question 2. Now for question 2. What is the recommended way to add data when using the Azure OpenAI on your data? Using any data source option available for Azure OpenAI on your data? Using Azure AI Studio to create the search resource and index? Or connecting to files in a storage account without using Azure AI Studio? You can pause the video here and take some time to think about your answer before we move on to question 3. Finally, let's see question 3. What are some recommended prompt engineering techniques when using Azure OpenAI on your own data? Break down the task and use chain of thought prompting. Include as much conversation history as possible in your call. Or use a single long prompt to provide all necessary information. Here, you can pause the video if you need to and take some time to think and make a note of your answers before we see the correct answers and their explanation. Are you ready? Let's see the answers. For question 1, the correct answer is to use supported AI chat models that can reference specific sources of data. If you plan to use OpenAI, you cannot create your own model to access the service without an approved subscription. For question 2, the recommended way to add data when using Azure OpenAI on your data is to use the Azure OpenAI Studio to create the search resource and index. You can connect an existing service, however, adding data this way allows the appropriate chunking to happen when inserting into the index, which brings us better responses. And for question 3, the correct answer is to break down the task and use chain of thought prompting. Prompt engineering techniques apply regardless of what data you're using. Adding as much conversation history is not recommended, as there are token limitations when it comes to using your own data in comparison to the model data. How many did you get? If you didn't do well, don't worry, you can always go through the videos or use a learning pass in Microsoft Learn. I hope you enjoyed this interactive quiz, and thank you for watching. Stay tuned for more challenges.